Mastering data virtualization. Data virtualization's dark secret: not all data is created equal. Where can various types of data, such as structured, semi-structured, and unstructured data, be virtualized, and what are the limitations of this process in terms of data sources, formats, and scalability? In a heterogeneous data environment, diverse types of data, including structured, semi-structured, and unstructured data, can be virtualized from various sources. The virtualization process involves abstracting the complexity of the underlying data sources, providing a unified view, and making the data accessible through a single interface. Structured data, typically found in relational databases, can be virtualized from sources such as 1. Relational databases: Oracle, Microsoft SQL Server, IBM DB2, and PostgreSQL. 2. Data warehouses: Amazon Redshift, Google BigQuery, and Teradata. Semi-structured data, characterized by having some level of organization but not conforming to a rigid format, can be virtualized from sources like 1. NoSQL databases: MongoDB, Cassandra, and Couchbase. 2. XML files and JSON files, which are commonly used for data exchange and storage. 3. Log files, such as Apache logs and application logs. Unstructured data, lacking a predefined format, can be virtualized from sources like 1. File systems, local file systems, network-attached storage (NAS), and cloud-based storage services like Amazon S3 and Microsoft Azure Blob Storage. 2. Email systems, email servers, email clients, and email archiving solutions. 3. Content management systems, CMS, SharePoint, Drupal, and WordPress. The limitations of data virtualization lie in the following areas. 1. Data source limitations: some data sources may not be accessible or may have restrictions on data extraction, processing, or transmission. For example, some legacy systems or proprietary databases might not provide APIs or have limited connectivity options. 2. Format limitations: the virtualization process may struggle with complex or proprietary data formats, such as those used in specialized industries like healthcare or finance. In these cases, data transformation and cleansing may be required to make the data usable. 3. Scalability limitations: as the volume and velocity of data increase, the virtualization layer may become a bottleneck. This can be addressed by implementing distributed architectures, load balancing, and caching mechanisms to ensure high performance and availability. 4. Security and governance limitations: virtualization may introduce security risks if not properly secured, and governance policies might restrict data access or usage. Implementing robust security measures, data encryption, and access controls is essential to mitigate these risks. 5. Complexity and integration limitations: integrating diverse data sources and formats can be complex, and the virtualization layer may need to accommodate varying data models, schemas, and data quality issues. To overcome these limitations, organizations can 1. Implement a federated data access approach, which allows for the integration of multiple data sources without replicating the data. 2. Utilize data profiling and data quality tools to ensure data accuracy and consistency. 3. Leverage data transformation and mapping capabilities to handle complex data formats and structures. 4. Implement caching, indexing, and query optimization techniques to improve performance and scalability. 5. Establish robust security and governance policies, including data encryption, access controls, and auditing mechanisms. By understanding the sources, formats, and limitations of data virtualization, organizations can effectively integrate and utilize their diverse data assets, providing a unified view and facilitating informed decision-making.